the main topic in 8.3 is not only the margin of error, but also the main topic is the determine the required sample size. So for the sample size, we have to know what is the margin of error. Look at this. Who was this? Actually, it was the second part in the confidence interval. We defined a confidence interval x bar, point to estimate the sample mean, plus and minus this one. You know, the second part has a name. That is the margin of error. Because who was that? Sigma over square root of n. You know, it was the standard deviation of the sample mean. What did I say? Standard deviation of sample mean. In another way, we call this one is a standard error. Standard error of sample mean. I'm sorry, yeah, it's the same thing, it has many names. You know, somebody called me the Daiho, Daeho, Dr. Professor yeah. It is I am, right? Yeah, I'm so sorry, it's the same thing, you know. X bar, sometimes X bar can be called sample mean. Point estimate for unknown population mean. Yeah, it is. So it was called standard deviation of the X bar, the sample mean. But now I can say is another name, standard error. You know, actually the standard error, it is a measure of the error. You know, the very beginning, I told you the main goal in statistics was minimize the error. Right? Do you remember that? It's minimize the error. You know, the standard error, it is the measure of the error. Smaller is better. Absolutely, the smaller is better. But when I multiply the z-score, yeah, we just took the z-score from a given confidence level, 95%, and sometimes it's 90%, right? So simply multiply the z-score from the confidence level, then we change the name. It is not just standard error, but it has another error. It has the name, another error, the margin of error. It's nothing. Yeah, we just name it. The second part in the confidence interval, it is the margin of error. Then say the margin of error has the z-score times standard error. Does it make sense? Yeah, that is nothing. So we define a new name, the margin of error. The main topic is determine the sample size. Okay? Determine the sample size, it is very critical. It is a very critical problem. You know, look at this one. I told you it had a new name, standard error. The measure of the error. Smaller is better. How can I make smaller? Here's a ratio. If I want to make smaller, how? Larger n. Take more sample size. If I can make bigger denominator, then the ratio is getting down. Does it make sense? Very simple. Select more. I told you the main goal in statistics is to minimize the error. How? Maximize the sample size. Maximize the sample size. I mean that is not the only way, but that is the easiest way. Select more. We can minimize. We can make smaller error. Very simple. Then what is the problem? What is the problem to make bigger sample? How do you think? What is the problem? Make bigger sample. We have to pay more. Think about the survey. I want to make a survey, then I have to make the questionnaires. It's a paper. How much is one copy at the library? One copy. How much? You don't pay anything? You know, usually it's 10 cents. It's about 10 cents, right? If I make the questionnaires with the 5 sheets, one questionnaire, it costs 50 cents. If I want to make 100 sample size, how much should I pay? 50 cents times 100, $50. If I want to make 1,000 sample, I have to pay $500. Everything is money. Yeah, we knew it. More is better. Yes, why not? But if I want to collect more, I have to pay more. So we need the optimal sample size. That is this one. In this way, we can make the optimal sample size. You know, but it is nothing. It is nothing. But look at this. The margin of error was a constant, z-score. Just a second. Let me write again. Let me write again here. Just a second. In the middle. The margin of error was the constant, the z-score times sigma over square root of n, the standard error. Okay? If I want to delete the z, what should I do? Divide by the z, right? We have to do divided by the z here and divided by the z there. Then we can cancel out the z on the right hand side. Does it make sense? Right? If I want to delete the sigma also, how can I do? Yeah, it's the same thing. Divided by sigma and divided by the sigma 2. Then now I can cancel out the z. Does it make sense? Okay, let me rewrite. Yeah, it messed up. Yeah, just a second. Let me make the space. Yeah, here. So the remaining terms are E over z times sigma is 1 over square root of n. So far so good? Can I flip? I mean, the z times sigma over E. What I did? Just flip. Who will be? It's the same thing. I should flip on the right hand side. So simply the right one will be square root of n. It's good? Now, I want to delete square root sign. What should I do?
Square.
Take the square. Then we can cancel out the square root. Now, on the right-hand side, there is the only n, who was the sample size. Who is this? Z times sigma over E, then square. Does it make sense? It is. Look at this. Sample size n can be determined Z times sigma over E square. Who is E? E was the margin of error. You know, exactly the formula for the sample size from the formula for the margin of error. So we just use it. Okay? So here's some examples. Let me copy the formula. The n is constant sigma over, let me say the ME is not just E, ME, the margin of error. Then square. It's good? Okay? So let me plug the one by one. The z-score. You know, actually, we took the z-score from the confidence level. The confidence level was given, 95%. To remember who was the z-score for 95%? We found the z-score for 95% confidence level. We put confidence level 95% in the middle, take 5% from 1 minus 0.95, split 2 parts. So the left end probability was 0.025. So we looked for 0.025, 0 on the z table. We found plus and minus 1.96. So let me take the positive one because we are going to take the square. So it doesn't matter the sign. The negative sign, take square, will be positive. So I just plugged this 1.96 for the z-score from the 95% confidence level. We are going to take the other confidence levels. I mean, we are going to take another z-scores from another confidence levels is later. But we found 1.96 from 95% confidence level. And can you see the sigma? Yes, here. Sigma was assumed to be known 12.1. Yeah, plug it. 12.1. And now we need the margin of error. Can you see the margin of error? Within 0.5. See, confidence interval was formed, point estimate x bar, plus and minus the margin of error. Plus and minus the margin of error. So it describes within plus and minus. Within 0.5. So the 0.5 is the margin of error. Plus and minus within 0.5. So we plugged all. Then what? Take the square. Please. Please.
2249.79.
2249.798.
No, 79. Oh.
Yeah. 79. 0.79 will be 0.8. Yeah. Did you get it? Who is this? Sample size. Just a second. Sample size. It can be 0.8, 0.79 sample size. You know the sample size must be whole number, integer. How do you think? What will be the answer? How many do we need? 2250. You should make the whole number because it is a sample size. How many counts? Does it make sense? Okay, let me give you another example. If you take 2249.2, how many will be? 2200? 49? I'm sorry, no, 50. Always round up. Please. Round up. Always. Because I have to say, at least, we need a sample size at least 2249.2. What was the meaning? What was the meaning? At least or more. Okay, so be careful. Always round up. Remember, round up. Here's another example. Here's the interpretation. See? If we take 2250 people, we survey 2250 people, then we satisfied 95% confidence interval, 95% confidence level, and we can make estimation within 0.5 based on the assumed sigma, the assumed population standard deviation. So that is the way to get the sample size. But additionally, here is the second part to make the confidence interval. So let me finish it. So it's actually in chapter 8. Chapter 8 has the two topics. One is the confidence interval, and additionally, the sample size, the two topics. So the confidence interval was point estimate, sample mean, plus and minus the z-score times sigma over square root of n. The sample mean is given here, 38.8. And the z-score from the confidence level, 95% again, which was 1.96. And sigma was given in the example, 12 here, 12.1. And now, how many sample size? We determined the sample size, which was 2250. Can you give me the margin of error? Please, the margin of error, the second part. How much is the margin of error?
0.5.
15?
0.5.
0.5. No? You didn't get 0.5? Anybody?
What is it? Is it a
0.49, 0.5? 38.8 plus and minus? Why don't you give me the interval form? Take subtraction, take addition. What is the smaller one from the negative? Subtraction. 38.39, comma, and the bigger one, 39 point, just a second. Did you say the bigger one, 39.29? Thank you. Then what is the smaller one?
0.31. 38.31.
38.31. Thank you. So either one would be good answer. This form or that form. What is this? 95% confidence interval.